Right now we're about to do the electrolysis of water lab. As set up here, we've got a pipette, a long stem pipette with the stem cut off the top, with a 1 molar solution of magnesium sulfate. I've used these dissecting pins inserted into the sides. We're going to use those for electrodes. And right now we see there is no electrolysis. And we will connect it to the battery. Observe what happens. Closely, we can see that now, get this to focus, there are bubbles coming off the electrodes as electricity flows through. Now the pure water itself, we have to use magnesium sulfate or some kind of salt or electrolyte in there to conduct electricity, because pure water will not conduct electricity on its own. You see gases being given off, and that would be the splitting of water into hydrogen oxygen gas. And we will should have that elevated. You can do it from the angle over here. So I'll hold my finger over this for a few minutes. Some matches. Build up a little bit, and this flame is we're using as the activation energy. We'll give this a little squeeze, and we'll get a little explosion. Still producing. Usually the first one gives you the biggest bang. So we had the electrolysis of splitting of water. It's a hydrogen and oxygen gas. As we squeeze it out of here and had the activation energy, we had a combustion reaction, and in which the hydrogen and oxygen gas recombined in a synthesis reaction and a combustion reaction to form water again and give off energy. So therefore that was an exothermic reaction. Here we see this was not spontaneous. We had to add energy into it to get the splitting of water. So it's an endergonic reaction. We put energy in, but it's not heat energy, so it's endergonic. This was exothermic because we had heat energy being given off. So we can do it again. Back it off just a little bit. And that's basically it. And there's some reactions, of course, going on with the ions and the electrodes. You get a little precipitate forming there. And we'll go on to our questions. I have the answers right over here on the board. This thing about the videos, you can pause, rewind, watch things again. So, why can't pure water be used in an electrolysis reaction? Pure water cannot be used in the electrolysis reaction because it does not conduct electricity. Water must contain electrolytes in the form of ions formed when acids, bases, or salts are dissolved in it. Question 2. What causes a drop of liquid to rise in the stem of the pipette? We had a liquid in there. During the electrolysis, as the oxygen and gas are given off, it rises through, so that would push the liquid from the stem. Three, what evidence suggests that gases are being produced by electrolysis of water? The gases produced came off the electrodes while hooked to the 9-volt battery. So once we started the electricity flowing through it, then we started seeing the bubbles formed. What evidence suggests electrolysis is a non-spontaneous reaction? Electrolysis does not start until the electrodes are hooked to the battery. Until you have a closed circuit and the current's flowing through it, we didn't see any bubbles coming off the electrodes, so we didn't see anything happening. Discuss possible source of energy that could be used to produce inexpensive hydrogen by a small-scale electrolysis. Possible source of energy that could be used to produce inexpensive hydrogen by small-scale electrolysis is wind, solar, geothermal, maybe hydroelectric. So I would find that's not very environmentally sound now. 6, and there's 2 extra points we want to make. The reaction 2H2 to 2H2 plus O2 is a decomposition reaction because one reactant is broken down to 2 products. It's also an endergonic reaction since energy went in to drive the reaction. And the last point, the reaction 2H2 plus O2 to produce 2 H2Os and energy in the form of our little explosion is a synthesis reaction since the 2 reactants produce 1 product. It's also a combustion reaction since it used oxygen and gave off heat and light. It's an exothermic reaction because it gave off heat energy. So these are the major points. It's also a redox reaction. You notice that those 2 reactions are reverses of one another too. And that's it.